We continue with our preparation for the exam, and our next question would be what is represented by the following. So question is, what is the Cartesian representation of the following? So put the absolute value again. Sorry, the wrong color. Need the white color. Absolute value of z, say plus 4i, equals, now we go to the imaginary part of z. So as seen before, we can see what the Cartesian representation is if you use the formula that says that z absolute value is square root of x square x square plus y square, where z is represented by x equals I plus iy. So if you use that, you can get the, see, that becomes the formula. So what do we say? Absolute value of x plus y plus 4i is imaginary, the part of z is y. So if we group the like terms, we get x plus I, y plus 4. Absolute value equals y, and the absolute value is the formula, and that's the square root of x squared plus y plus 4 square equals y. Then we both sides put in the power of 2, they lose the square root, plus 4 equals y squared. And now we expand this, becomes x squared plus y squared plus 2 times 4 is 8, y plus 16 equals y squared. And then we lose y squared here, because on both sides divided by y. So because no, sorry, divided by more minus y squared on both sides. So use here, use this with 0. So if we continue here, we got x squared plus 8y equals okay, plus 16 plus 16 equals 0, and therefore 8y equals minus x squared minus 16y is equal 1/8 minus 1/8 x squared minus 16, and it's a parabola. So that's the answer, our answer. The Cartesian representation of this. That was our question 4. Question 4. Let's now go to next question. First get rid of this. Okay, won't take long. Let us draw the question 5 is find the equation of the representation on the graph. So say this is our graph. So this is our real part of Z and our imaginary part of Z. So say number 1, number 2, number 3, 1, 2, 3, and we draw a line here and a line here. And we say we want to represent that. What give us an equation for that? So what we can see, if we draw a line in the middle, we can see that the distance from this line to the other two lines is constant, and it's 1. So if you remember before what we said, that absolute value of Z, say minus 1, absolute would be the distance. So this 1 we represent like Z1, that is x1 plus yi1. And then it's also, so the distance between this locus of points Z that have coordinates x and y. So that's important because the coordinates x and y, and here x, y, and y1. So the distance, if is 1, we say. So the distance between these complex two numbers, because this every complex number is an point on the diagram. So this point Z1, if you let then x and y from Z be anything and the distance is 1, would turn into a circle around here, would be a circle. So if you just remind you that Z minus 1 absolute value is the distance between Z, which is any points x and y, any x and y coordinates on the distance of 1. This is the distance, because remember the formula of Z absolute value represents the distance, the length of the complex number. So if you remember that the complex number Z, so this length here, so it's the distance from the origin. So the distance between, so it's always when you say for example 5 minus 3, that's the distance between, so that's the distance between number 5 and number 3, because if you go 0, then that length here minus length here is that length there, so that's number 2. So that's minus represents the distance, right? So the distance between set of points like that written will be a circle, but we don't want, this is not a circle. So what we can see that the distance between number 1, so this line here represents x equals 1, and this one represents x equals 3. So the other coordinate is, so the equation, this line is x equals 1, x equals 3. So the imaginary part is 0. So the distance between this line here in the middle, so it's just the real part, So this is just the real part and the real part of z. So if you could say then that the distance between the real part of z minus this real part of 1, so sorry, here is not 1, it's 2, I apologize. This number is 2, it's the middle. So between z and 2, not 1, between z and 2, this equation here is x equals 2, but that's our x1, right? So if we say that distance between the real part of this z number, the locus of point z, and the real part of this z1, which is 2, the distance between the real parts, it's just these two lines, will be always 1. So that is our equation. So that's the solution for answer 5, for the question number 5, equation of the representation on the graph. In this case, two vertical lines. Let's go next question, number 6. I'll change the color. Question number 5. Now question number 6. We go, what is the locus of the following equation? The locus of the following equation. So let's we know how to do that. So let's say z minus 4i equals z minus 4. So we said how we resolve that. What's z? Z is, as we said, we need to evaluate that. We need to use this formula. That z absolute value is x squared plus y squared, and then we get what it is. So just solving the equation when you do that. So you get x plus I y minus 4i absolute equals, just a matter of doing it, x plus I y minus, when you have an idea, right? So that's different there, that's different there. So absolute, so group like terms. So you get x plus I in the bracket y minus 4 absolute, and here x minus 4 absolute minus I y absolute. So that's square root of first one, so x squared plus y minus 4 y minus 4 square. There we need to remove that. And the same here, x minus 4 square minus y square plus y square, and on the power 2 on both sides, so we got x square equals, plus y square minus 8y plus 16 equals x square minus 8x plus, here you got 16 plus y square, and here you got x squared, take away from both sides, and what else you got? you got minus y squared plus 16 on both sides. And what's left? Well, let's do it here. What's left is minus y squared minus 8y equals minus 8x plus y squared. And oh, sorry, we have plus y squared here because it's that's plus there, plus y squared and plus y squared gone. So you don't have y squared here at all. And here you don't have it either. So what you left, minus 8y equals minus 8x. So divided by minus 1/8, or multiplied by minus 1/8, both sides, multiplied by both sides to multiply by that, and you get y equals x. So that represents a line. So if you want to draw it, so that's y equals x, real of z, imaginary of z. That's the locus of the following equation here. Is the equation. And here is the locus. So that's our question 6 answered. Let's go to our question 6. This one is going to be a very good one. So let's find find the representation of a line in complex plane. So let's draw one line. Say that line goes, so let's go the numbers of 1, 2, 3, 4. And here maybe 1 and 2 and 3 and 4, and here is 3 halves. So in here let's go same 1 and 2 and 3 and 4. So minus 1, minus 2, minus 3, minus 4. And let's draw a line. Then goes through this point here and to the point here. So the line would go all the way to these 2 points. It's our line. So what's the equation of this line in the complex plane? So first we get the equation of the line. First we find the equation of the line in Cartesian plane, in Cartesian, not complex, sorry, Cartesian plane. So how do we do that? So we have 2 points, right? So let's see this point, we call it M1, and this point we call it M2. So M1, this point is M1 and this is M2. So what are the coordinates of our M1? They are 0 for x and -3 for y. And here we have coordinates of M2 are 3/2 and 0. So to get the equation of the line is of the x plus c. That's a generic one. How do we get m? M is the slope. So what's the slope? It's m is equals y2 minus y1 divided by x2 minus x1. So what's that? M is equal to y2 is 0 minus y1 is -3 divided by x2 is 3/2 minus x1 is -0. So what we got? We got +3 divided by 1, of course, divided by 3/2. So 3 and 3, and the result is 2. So our coefficient is 2, so our line looks m equals 2 mx plus c. What's our c? So that's like what the line goes up by. In this case, so that's y equals x. If you look at just that, there's just a line passing through here from the origin. But this one is going to move down by 1, 2, 3. So c is -3. So the equation of the line becomes 1 equals 2x minus 3. So that's our equation of the line. That's our A. So we got the equation of the line. So this line here is equal y equals 2x minus 3. So it's in Cartesian, but we want it in the complex plane. So, how do we do that? Well, there are two ways. So we can answer the first one very easy. So if you want it in the form of real and complex parts, then you can answer it easily. So the answer 1 of question 6 would be, if y is equals to x minus 3, then we can say that if we see that z is equals x plus cy, then we can say that the real part, so the imaginary part here, so we can say the imaginary part of z is equal to 2 times the real part of z, and minus 3. So that would be our answer one way. So this will be answer 1. But we wanted, what if answer 2 requires it in the form z minus something. So that's what we're gonna do with that. So our answer 2 of 6 could be the following. So we want it in a form of z. Remember, the line can be, it's equidistant. So if you say, for example, choose 2 points here and call them z1 and z2 that are equally distant, so it's right angle here. So this distance here, so is equal d. Then we can, and now every line here can be described equally distant from from there and there and there. So these are, so that wasn't quite a right line. So each line, each point here is equally distant from the distance here and distance here are the same. So we can then for each point say the equally distant from these two. So equally distant from these two numbers are in compass plane. So what we wanted, we want something that looks like z minus z1. The distance from that is the same as the distance of z from z2. But z1 is not known. Neither z2 is not known in our case. So we need to get them. How are we going to get z1 and z2? Let's back to our white color. Oh, we can do it like this. So first we select, so I hope this was clear there, so we'll need this space here. Just explain that. I need to remove that because we need the space. Okay, now let's say if we draw a line that is perpendicular on this line and goes, pick a number. So we'll pick a number 4. Let's pick a number. And then we go, this is in the right angle. And we go there. So, this is not right. I'll just make it more straight. More straight line. And now we want to say, what is the other point that the equidistant? So we want some point here that the distance here and the distance here are the same. So that will be our z1 and z2. So we call this point here z2 and we call this one z1. So we see the coordinates of z2 are 4 for x and 0 here. And the equation of this line here, because it's perpendicular, let's get first the equation of this line. What is the equation of this line? So we know that we call it y2. So y2 line, the equation is, it has its own m2 times x plus c. So it's m2. We know the relationship equals n1 and m2 because it's perpendicular. So it's m1 times m2 equals minus 1 because we know that because the lines are perpendicular. So from there you're getting that m1 is 2 times m2 is equal to minus 1. From there we're getting then m2 is equal to minus 1 half. So therefore our equation becomes y2 is equal to minus 1 half of x plus c. So we are left now to get this c. Because the line goes to the point 0, 4, 0, therefore we have that 0 is equal to minus 1 half times x, which is 4, plus c. from there we are getting that C is equal to plus 2. So 4 divided by 2 is 2, minus 2 on the other side plus 2. So we got 6 plus 2. Therefore, our equation for line here, equation line 2, becomes minus 1/2 of x plus 2. So now let's make that more visible. So that's our equation for line 2. This is our equation for line 1. Let's make more room now. Now, we got the equation of the line. So now we need to know the distance. How do we get the distance? First, we know what is this point here. That point, we call it point A. What are the coordinates of this point A? So obviously that's the intersect of these two lines. So we have that 2x minus 3 is equal to minus 1/2 plus 2. Minus 1/2 of x plus 2. From there we're getting that 2x plus 1/2 x. That's how many? It's 4/2 plus 1, 5/2. So you get 5/2 of x is equal to 5. Minus 3 on the other side is 5. Therefore, x is equal to 2. So how do I know? Well, obviously, if multiply here, divide on the other side, so it becomes 1, and 2 divide here becomes multiply there, becomes 2, so x equals 2. So the first coordinate is 2. How do you get y? On the intersect, or replace in one of the equations. So if I replace this is x equals 2, I replace it there, then I've got y is equal to 2 times 2 is 1, minus 1 plus 2 is 1. So we're getting that y is equal to 1. So our coordinates of our intersect there are 2, 1, 2, 1. So our point A has coordinates 2.1. Let's make more room. Now, how are we going to get this point here? Let's change the color. What I would do the simplest way, instead of using the distance, because the distance involves the square root of x squared plus y squared, so it's and then you use square root and you're left with powers of 2, which is hard to do. So the easiest one would be you draw a line here. And you say, how much did I lift this line up by? I lifted it by 2. So I lifted this line by 2. So the distance between this point and this point here is 2. So I lifted it by 2. If I lift it for another 2, so it's plus 2 plus 2, and then find the intersect. So if I lift it for 2 and go there, then where they cross, that point there is equally distant from here to here and here to here. These distances are then equal if you just move this line, new line. So what's the equation of this line? So quickly to recap, so we want the easiest way to get the equation is we lift one line up to get this distance. The easiest way to get, instead of going d equals square root of x squared plus y squared, which gets us into squares and square roots too hard, then we go parallel line through this intersect point, lifting it up from whatever the distance is. So it's 2 points up plus 2 is 4. What's the equation of this line? The equation of this line here is y equals 4. So what's this point here? It's simple, it's the intersect of these two. So what we are getting in this point here is 4, first equation, y equals 4, and the second one is equals minus 1/2 of x plus 2. So that's the equation of y equals 4 and intersect with y equals 1/2 of x plus 2, minus 1/2 of x plus 2. So that's that up there. So what that becomes, it becomes minus 1/2 of x is equal to 2. Therefore, that becomes that x is equal to, multiplied by minus 1, so you got minus 2, and 2 goes there, x equals 4. So 4 divided by 2 is minus 4. X is minus 4. Minus 4 divided by 2 is minus 2, and this minus is plus 2. So that coordinate there is x equals minus 4, and what's the other coordinate? Is obviously 4. Sorry, just a notice here, the coordinates is 2.1, so x is on 2, y is 1, so this is only 1 here and 1 here. Therefore, y equals 2 is the equation, y equals 2. So I apologize for that. Y equals 2. So what does that become? So it comes here as well, y equals 2. Y equals 2. So what does that become? Here we have equals 0, and we get that x is equal to 0, and obviously y is equal to 2. So the coordinates of z1, so we have z1 has coordinates of 0, 2. So this picture doesn't represent it just right, because my drawing, but this should be on this line here. That basically should be here. So just the picture is not drawn correctly, but everything else is okay. Because see the scale here 1 and here 1 was bigger, so you know what I mean, everything will be going down. So we have now coordinates of z1 and coordinates of z2 that are here. So we got coordinates of z2 and coordinates of z1. And now we can write finally our formula becomes absolute value of z minus z1, which is 2I. So that follows that is absolute value of that is equal to absolute value of z minus z2, which is 4 for the real part and nothing for. And that's the final solution. That's answer 2. Answer 2 of 6. That's the equation. So the equation, so either it is, so two answers are this answer here, that's answer 1 and answer 2. Two ways. I hope you enjoyed this one. Just the imaginary parts should be going through that one. Not good drawing. That's all.